Well, welcome to a semester on probability and statistics. This is our first unit, which is on the nature of statistics, where we're just kind of getting a big 300,000 mile picture of statistics. We're not getting down into the details of it just yet. And what we're going to be learning today is two different things, two different types of statistics that we'll be studying, and then also two different types of studies. Okay, so let's go ahead and get started. So the first thing we're going to learn about is the difference between inferential statistics and descriptive statistics. Descriptive statistics is where you just describe an entire population. So that's where we sample an entire population and just kind of summarize what's going on in that population. So if we were doing a descriptive study about Homestead students, we would ask, or we would look at the entire population of Homestead students and say that, I don't know, 52% of them are female, or 28% of them are freshmen, or just looking at the entire population. Inferential statistics is a little bit different because we're inferring something about the entire population based on a particular sample. So if we don't want to work with the entire population, we might sample maybe 100 students at lunch and find out what is their favorite type of food in the cafeteria. And based on that sample of 100 people, we would infer that that's also true about the entire population. So inferential statistics is probably not quite as accurate as descriptive statistics because we're making an assumption that the sample represents the population. The second thing that we're going to be talking about is the difference between an observational study and a designed experiment. And real quickly, an observational study is just a study about a particular population. Population may not even know they're part of a study. For example, if I said that 51% of Homestead students were females, that would be an observational study. You didn't even know you were a part of this study. We were just looking at the entire population. Where a designed experiment would be something where you put the different groups in, or the population into two different groups, and maybe maybe it's on a particular drug and the effects of a type of drug that a group is taking. We would give one like a placebo, and then another group the actual drug, and then kind of discuss what the differences are based on whether they were getting the placebo or the actual drug. And if it's a designed experiment, then we can say there's a causation. The drug is causing certain side effects, or the drug is causing maybe cancer to decrease or whatever. If it's an observational study, then the best we can do is say that there's a correlation between two things, but we really can't say that there's a causation. And we're going to get into that in this video. So let's take a deeper look at descriptive statistics. Descriptive statistics consists of a method of organizing and summarizing information, the entire population. So we're just summarizing, we're organizing and summarizing an entire population. We can do that with graphs, charts, tables, calculations such as averages, mean, median, mode, that type of thing. That's all descriptive statistics. An example of a descriptive statistics would be something like this. In 1948, you may not be interested in baseball, but this is a descriptive statistics about the Washington Senators. They played 153 games. They won 56 of them. They lost 97 of them. They must not have been a very good team. They finished 7th in the American League and were led by Bud Stewart with a batting average of .279. So that's just a descriptive statistics about the 1948 Washington Senators baseball season. Here's something that's not descriptive. It's inferred. And so here's a big difference. It's inferred. Donald Trump's approval rating is at 50%. Now, whether you're a Donald Trump fan or not, they probably didn't ask anybody or everybody in the entire population of the United States on whether or not they thought Donald Trump was doing well or not doing well. It's an inferred thing. Maybe they asked 5,000 people. Maybe they asked 1,000 people. And that was a sample. And what they did is they took that sample and then applied it to the entire population. And there's certain things that allow us to do that, certain things that are kind of assumed when you do that. And but this is an example of inferential statistics. So inferential statistics consists of methods for drawing conclusions about a population based on information obtained from a sample. Okay, and that's what an inferential statistics consist of. Most of the studies that we hear about today are inferential statistics. If somebody does a study, they have to sample a certain group of people, and based on that sample, judge what the entire population would think. All right, so we talked about population and sample. The population is all the individuals considered in a study. So the population could be all of Homestead students. Okay, a sample would be just a group within that population that are asked certain questions or that are surveyed. Population could be the entire population of the United States, but a sample would be only the people in the United States that were asked to respond to a survey. And so there's a difference. Population is always bigger than the sample because the population is everybody, and a sample is only a certain group of people within that population. All right. So example of an inferential statistics. So let's say political polling provides, most of the time this is true, political polling is usually inferential. The only time that it's not is when we actually have an election. Then it's an election of the entire population because everybody in the United States can vote. And even then you can argue that and say that only the people who voted would be the sample. You might have a president that's elected even though the majority of people wouldn't have voted for them if they had the choice, but the sample of people who did vote actually did vote for them. When we hear statistics about whether this candidate would win an election over another candidate, those are almost always inferential because they can't ask everybody in the United States what they think. They can only ask a certain number of people just because of time and convenience. So we have an entire population, which is including everybody, but a sample might be only a certain number of that population that consist of the sample. All right, so let's classify some statistical studies. So the 1948 presidential election, there was Truman and Dewey. Truman won by 49.7% of the vote. Dewey finished in second with 45.2% of the vote, and so on. This is an example of something that is not an inferential study. This is a descriptive study because it just summarizes what has happened in a particular election. So this is a descriptive study. All right, how about this one? Top filmmakers of all time, okay, and the American Film Institute conducted a poll of 1,500 film artists, critics, and historians, asking them to pick their 100 favorite films from a list of 400. The films were then, the films on the list were made between 1915 and 2005. After tallying their responses, the American Film Institute compiled a list of the top 100 films. So suppose this is the statement that comes from the study. Consider the following statement. Among the 1,500 film artists, critics, and historians polled by the American Film Institute, the top-ranking film was Citizen Kane. Well, would that be, what type of study would that be? Well, that would be descriptive. There's no inferences made. They're just summarizing what those 1,500 film artists and critics said about their top films. So that's descriptive. Now, let's say we change the statement to be something like this. Based on the American Film Institute poll, Citizen Kane is the top-ranking film among artists, critics, and historians. Well, now it's not descriptive, it's inferential, because they didn't ask all artists, critics, and historians. They had to have asked just a sample. And so that sample was only 1,500 of them. And they made an inference that the entire population of all artists, critics, and historians believed it the same way or thought the same way that the sample did. And that may or may not be the case. All right, so at this point, we should be able to describe what the difference is between an inferential study and a descriptive study. Let's go on to the second part of this lesson, which is observational studies versus designed experiments. An observational study is where you simply observe characteristics and take measurements, as in a simple survey. So you can be a part of a study, a population could be a part of a study, or it could be a sample that's a part of a study, and you're just summarizing what that sample says or what that population says. A designed experiment is where you impose treatments. You treat one group different than another. One is called the control group, and the other is the treatment group. And you observe characteristics and take measurements based on whatever it is that you're studying in that group. So for example, let's take a look at this. In 1977, getting back to baseball, the first 616 games in 1976, there were 726 home runs. But in the first 616 games in 1977, the home runs increased to 1,033 home runs. So they wanted to figure out what was causing it. So they thought, well, maybe it was the baseballs. Major League Baseball switched from Spalding baseballs to Rawlings baseballs in 1977. So they did a study on 85 baseballs from different years, from 1952, 53, 61, 63, 70, 76, and 77, and measured the bounce, the weight, and the hardness of these baseballs. The result was that in 1977, those baseballs were livelier, which means they bounced more, maybe they were a little bit more hard, maybe they weighed more or less. I'm not sure what would make them bouncier. But they were livelier in 1976 than the 1976 baseballs, but not any of the other years. So is this descriptive or inferential? And this would be an inferential study because we're inferring, we only selected 85 baseballs. So this is an inferential study because we're assuming that those 85 baseballs in each of these different years represented all the baseballs in those years. So it's an inferential study, but it's an inferential statistics, but it's also an observational study because it only took measurements of the characteristics of the baseballs. They didn't impose certain things on certain baseballs and not on the other baseballs. They just kind of summarized what was going on with the baseballs in those given years. So this is an example of an observational study. Let's take a look at a different situation. Well, before we do that, that means that there is a correlation. There must be a correlation between the 1977 baseballs and the 1976 baseballs. And we can't really say that something caused them to happen. We can't really say that the livelier baseballs cause more home runs to hit. There's only a correlation there. And so we'll talk more about that in class, but let's take a look at a different study. A designed experiment would be something like this: folic acid and birth defects. For years, there was thought that folic acid reduced major birth defects. And so there was a study that took a look at 4,753 women prior to conception and divided them into two groups. Group A took a 0.8 milligram daily dosage of folic acid, and Group B took a daily trace amount of some other vitamin. And so we would say this is the control group and this is the actual treatment group. And then they took and looked at the comparisons between Group A and Group B. 13 out of every 1,000 of the women who took the folic acid had birth defects, compared to 23 of the 1,000 of those who did not take the folic acid. So those who did not take the folic acid had a higher percentage of birth defects. And so this is a designed experiment because the people doing the study separated the amount of women into two different groups, and they provided the treatment. And because they provided the treatment, that was the only difference in the 1,000 women who, or in the women who were in Group A and Group B. Now we can say that there's causation. Now we can say with pretty much certainty that if you took folic acid, that caused you to reduce the amount of birth defects in your baby. And that's a higher relationship than just a correlation. A correlation just means there's some relationship, but not that one is causing the other to happen. All right. So when you're working with on assignment 1.1 in Math Excel, that'll be your homework assignment. You're going to be looking at the differences between observational studies and designed experiments, as well as the difference between descriptive studies and inferential studies. You'll also learn when you conclude, when can you say that there's a correlation, and when can you conclude that there is a causation? And that's what assignment 1 is all about. So we will work on our homework assignment, and we will go over questions that you have on it tomorrow in class.